It's Algebra 2, study guide for test number 16. Got through logarithms. First one says write the equation in logarithmic form. The base is 4 that's being raised to the third power is 64. So it's going to be like this. Log base 4 of 64 is equal to 3. That's logarithmic form. This is backwards from the way we had been doing it. Log base 4 of 64 is equal to 3. We've been going the other way with it. Evaluating these logarithms, same thing. You're doing 3 to what power equals 1 over 81. You're making a fraction out of an integer, a number that we consider a whole number. So you're going to need a negative value for sure to make it ride the elevator. Then just count how many exponents you need to get from 3 to 81. 3 squared is 9. That's 2. 3 to the third power, you multiply that by 3, you get 27. 3 to the fourth power is 81. So 3 to the fourth power gives you 81. The negative makes it ride the elevator down. Therefore, it is negative 4. This is saying 6, the base, to the what power is equal to 1296. Okay, we're not riding the elevator. It's not changing fractions or anything this time. So now you're just saying 6 to what power? To the second power is 36. To the second power is 36. When you get to the fourth power, it's 1296. So 6 to the fourth power is 1296. Okay, number 4, we hadn't talked about when they don't have a base shown. There are base logarithms, which you consider normal logarithms. They have a 10 as a base when it's not shown. We'll talk about natural numbers where your base is e. We'll talk about that another day. We're not doing that on this test. But if a base isn't shown, it's 10. So what we have is 10 to the what power is 0.01. Now it's in a decimal form, so that's kind of rough for people. You can consider that this is the 10th place, and this one right here is the 100th place. So what that's saying is 100th. So 10 to the what power equals 100. So it's just like number 2. It's going to have to ride the elevator, so it's definitely going to be a negative exponent. And then 10 to the what power gives you 100. So it's real simple if you think about it that way. It's negative, and it's to the second power. We're writing this one in exponential form. So all you're doing is taking the base 32. You're raising it to what's after the equal sign. So you're raising it to the 3/5 power, and that equals 8. Just writing it in exponential form. Then we're going back to stuff we did before this week. Simplify the difference. Minus tells you the opposite of everything that's in the second set of parentheses. 7w squared minus 8w squared. 7 minus 8 is negative 1w squared. Negative 6w, again, minus 3w is negative 9w. Negative 8 minus a negative 7 means plus 7. Negative 8 plus 7 is minus 1. 5u to the third plus 8u to the third. 5 plus 8 is 13u to the third. 6u squared plus, there is no u squared in the second one. So it's simply a positive 6u squared. Notice there's 1 degree of u to the first power, and it's only in the second one. So minus 2u to the first power. And then the last one is the constant. 4 plus 2 is positive 6. 13u cubed plus 6u squared minus 2u plus 6. Then simplifying the products for 8 and 9. You multiply, you distribute. 6 times 4 is 24. That's simple. And then x to the 7th times x to the 3rd. Anytime you multiply the same bases, you add the exponents. So it acts like x to the 7 plus 3, which is 24x to the 10th. Distribute it to the other one as well. 6 times 4 again is plus 24. And then notice what we have on the next one. It's x to the 7th times y to the 5th. Different bases. So it's simply 24 x to the 7th, y to the 5th. You do not add them up and get 12 right there. They're simply multiplying next to each other. Do the same thing with number 9. Distribute 7 times 3 is 21. A to the 6th times a to the 4th is a to the 6th plus 4, which is 21. A to the 10th. Do the same thing and distribute 7 times negative 5. That's going to be negative 35. And then again, one's an A and one's a B. So we have A to the 6th, B to the 4th. Number 10, anything to the first power, 0 power is 1. Number 11, anything raised to a negative exponent has to ride the elevator. It goes down. 1 is left on top, 2 goes down, and it's now being raised to the 5th power. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 1 over 32 for that one. The only thing raised to a negative exponent for number 12 is C. It's the only thing that rides the elevator. 3 stays at the top. C comes up and it becomes to the positive 5th. D stays at the bottom to the positive 5th. All 3 of these are the same basis, 3, 3, and 3. So add the exponents. 3 to the 0 plus a negative 2 means minus 2 plus 5. 0 minus 2 is negative 2 plus 5 is positive 3. 3 to the 3rd. 3 to the 3rd is 9 times 3 is 27. 14, again, a lot of decimals showing and all that other stuff, but it's all the same bases. They're both 6.75. So 6.75 to the negative 6 plus 6 is 6.75 to the 0, and anything, just like a little while ago, to the 0 power is 1. There's a coefficient right here that's not shown. It's 1. When you multiply 1 times 3, you're going to get 3. Then you have the same bases. Both of them are x, so you're going to add 6 and 11. 3x to the 17th. You're going to multiply all of the coefficients. 6 times 3, it's 18. And 18 times 5 is 90. So you have 90 for multiplying all of your coefficients together. Then multiply the same bases together. Both of these are x. So x to the 5 plus 6. And there's only one y, and it's to the 8th. So we'll fix this up. 90x to the 11th, y to the 8th. 8h squared is being raised to the 3rd power. 8 needs to be raised to the 3rd power. And h squared needs to be raised to the 3rd power. Now, when you raise a power to a power, we're not adding them anymore. Now you're multiplying 2 times 3 to get h to the 6th. 8 to the 3rd power, 8 times 8 is 64, times 8 more is 32, 48, 50, 512 h cubed. Number 18, x to the 4th over x to the 7th. Remember, we've been doing multiplication for the last several numbers. Multiplication goes with addition of exponents. Division goes with subtraction. So x to the 4 minus 7 is x to the negative 3rd. If that's all you got, you didn't go far enough. Remember, you can't leave a negative exponent. Everything is over 1. This rides the elevator down. 1 stays at the top. X comes down and becomes to the positive 3rd. The same thing with number 19. You have 4 to the 6th over 4 to the ninth, it becomes 4 to the 6th minus 9 is 4 to the negative third. Ride the elevator again. 1 stays at the top, 4 comes down, and it's raised to the positive third. 4 times itself, 16, and 16 times 4 is 64. I should know that one. 1 over 64 is your answer. C squared, c to the 7th, d to the negative ninth, over c squared, d to the negative 4th. C to the 7 minus 2, d to the negative 9 minus a negative 4. Anytime you're dividing, you're subtracting. Even though you're subtracting a negative, it becomes minus a negative, which always means plus a positive. So you have c to the 7 minus 2 is c to the 5th. D to the negative 9 minus plus 4 is going to be d to the negative 5th. You can't leave it like that. You can't leave the negative exponent. C to the 5th stays on top. D goes down on the elevator, and it becomes to the positive 5th. Everything is being squared for number 21. 3 is being squared. That's 9. B is being squared. And 4 is being squared. And you get 16. There's no number that goes into both 9 and 16, so that is considered simplified. (22) Solving the equation. In order to solve an equation like this, you need to factor it, and you need to make it equal to 0. So if we want to make it equal to 0, we need to get everything that is on the right-hand side off the right-hand side. So if you move that over, you subtract 36, you do likewise right here to balance it, and what you're left with is 0 on the right. This cancels out. You have x squared plus 12x. Now what you need to do is you want to factor this. You want to pull out what x squared and 12x have in common. They both have x, and they both have x times x and x times 12. So we're almost finished. This is saying either x is equal to 0, and I said either, and x plus 12 is equal to 0. So again, x is 0, and when you subtract 12 on both sides, x is equal to negative 12. If you plug either one of those numbers in, you'll have a true statement, 0 and negative 12. You have a left side and a right side. This is an Algebra 1 problem. Negative 2 times y, you distribute it. Negative 2 times negative 7 is plus 14. Negative 4y minus 11. Put your variables on the same side. Bring your smaller to your larger. Negative 4y is smaller. Bring it over by adding 4y. If you add 4y to both sides, it leaves you with 2y on the right. You still have 14 there. You still have negative 11. You got 2y on the right. Bring the rest of it to the left. This is the rest of it. Bring it over. Add 14 to both sides, and it leaves you with 3 on the left and 2y on the right. One more step. Get y by itself by dividing by 2. Y equals 3 over 2. (24) Factor the expression. Remember, you're going to factor out, this is ax squared plus bx plus c. It's been a while since we said that, but now that that's changing. You're factoring out c, 12. Remember, it's 1 and 12, 2 and 6, 3 and 4. Which pair of those numbers will get you to b's value 1? Remember, 1 and 12 is either going to get you to 11 or 13. 2 and 6 is going to get you to 4 or 8. It has to be 3 and 4. So when we factor this out, x times x and 3 times 4. Those are your numbers. The signs are determined by the sign in front of C. It's negative. That means they're going to be different signs. Since they're different, the sign in front of B tells you the larger number is negative. 4 is larger. It's negative 4. 3 is smaller. It's positive 3. X plus 3, x minus 4. Remember, there is no such thing in real numbers as a negative square root or a square root of a negative number. The only way we can make this work right here is to multiply it by I and pull the negative out. So plus 5. We know that the square root of 4 is either positive 2 or negative 2, because 2 times 2 is 4 and negative 2 times negative 2 is 4. That's multiplying by I just reversed the order, and added 5. We wanted an A plus BI form, so just reverse the order one more time. 5 plus or minus 2 times I. Number 26 says solve by completing the square. This is not a value that we can make into a perfect trinomial. So what we need to do is we need to move that 19 over by subtracting 19. If I do it there, I have to do it here. What I have is x squared plus 8x plus c is equal to negative 19. That plus c is what we need to find. Remember, in order to find c, you take b, you divide it by 2, and you square it. B in this case is 8. So 8 divided by 2 is 4, and 4 squared is 16. So our new C value is 16. Since that one is adding 16, you have to do it to the other side of the equation or you'll unbalance it. If you take the square root of the first term, it's x. If you take the square root of the new C value, it's 4. This is the sign that goes between them. We're squaring that entire binomial, x plus 4. It's equal to negative 19 plus 16 is negative 3. Okay, in order to find the rest of this, we want to isolate x. So we want to cancel out x, this square right here. In order to cancel out squaring something, you take the square root of it. If you take the square root on the left, you have to do the same on the right. That'll cancel it out and give us x plus 4. We're almost there. Equals the square root of negative 3. Again, just like on the last problem, there's no square root of a negative number. Multiply the square root of 3 times I. One more step to do. Move the positive 4 over by subtracting 4. If you subtract it there, subtract it here. X is equal to negative 4 plus or minus the square root of 3 times I. And that just puts it in A plus BI form. '27 says rewrite it in vertex form. Almost the same problem as 26, except it'll be a little bit less to do at the end. You want to move, this is not a perfect C value, so you want to move it over. So when you add 2 to cancel out 3 to cancel out minus 3, you're left with y plus 3 on the left equals x squared minus 4x plus c. We need to find c again. Our b value divided by 2, negative 4 divided by 2 is negative 2, and negative 2 squared is 4. Again, if you add 4 to the right, your new c value, you have to add it to the left to balance it out. Y plus 7 equals, now we have a perfect trinomial. Again, take the square root of the first one, x, the square root of the last one, 2. This is the sign that goes in between them, and that entire binomial is squared. One more step to make vertex form. Vertex form is y equals x minus h squared plus k. Vertex form, I'm going to write that on the board for the test. So we need to get rid of this plus 7 by subtracting it from both sides. Y equals x minus 2 squared minus 7 is your vertex form. And remember, if you had to plot the vertex based on that, it's the opposite of what you see in the parentheses for x. So it would be positive 2, and it's exactly how it's written outside of the parentheses for y, negative 7. 28 says use a quadratic formula. Again, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. I'll write that on the board too. This is a problem when you do it. It's going to be real funky looking at the end most of the time. Everything still holds true though. This is still A, this is still B, this is still C. You just need to plug the values in. So negative B, B's value is already negative. So you're making a negative negative, so it's going to be positive 3 plus or minus the square root of B squared, negative 3 squared, minus 4 times A's value is negative 4 times C's value is negative 6. And all of that is over 2 times A's value again is negative 4. So simplify everything under the radical. Negative 3 squared is 9. So we have this now. 9. Negative 4 times negative 4 is positive 16 times negative 6. And all of that's over 2. It's plus or minus 3. And all of that's over 2 times negative 4 is negative 8. So we're almost finished. 16 times 6 is 36. So we have negative 96. Again, like I said, it's going to be a funky looking number at the end most of the time. Plus or minus square root of 9 minus 96 over negative 8. 9 minus 96, when we subtract 9 from it, is going to be 87. So it's going to be 3 plus or minus the square root of negative 87 over negative 8. Again, you can't leave that negative like that. X equals 3 plus or minus the square root of 87 times I over negative 8. And like I said, as bad looking as that is, that's the closest we can get to solving for X by using the quadratic formula. '29 says solve by finding square roots. First thing you want to do, remember, please excuse my dear Aunt Sally, is how you always do it. When you undo it, you go backwards. So you look for anything that's adding and subtracting first. We don't have that. You look for anything that's multiplying and dividing next. We got that 5 times x squared. So cancel that out. Divide by 5. X squared equals 15. Then get rid of that x squared by taking the square root of it. It'll cancel it out. If you do it there, do it here. X equals the square root of 15. And then it says simplify the radical expression by rationalizing the denominator. You can't have that radical at the bottom. That was one of the no-nos with those. In order to cancel it out, multiply the square root of 15 over itself, the square root of 15. Multiply straight across. When you do that, you get 3 times the square root of 15 over, when you multiply the same radical times itself, remember you can just pull what's underneath it and call it 15. This isn't enough though. We have one more step to do. Since 3 goes into itself once and into 15 5 times, the best answer would be the square root of 15 over 5.